Attendance is on, by the way. You guys can put it. Shall we wait for a couple more minutes then? It's only 25, the strength right now. Yeah, it's early morning. Sorry to wake you guys up in the morning. And make sure you put the attendance, by the way. It's raining quite heavily here, so I'm not sure what's. Yesterday, my broadband somehow worked, but I still don't know whether it will work today or not. So let me also have my mobile phone ready so that if. Okay, fine. So now I do have a alternate internet source as well. So if something goes wrong, I'll shift to that. I think we are enough now to start. 40 people should probably be fine. Um, I hope you guys can see my screen. I had to actually switch off my broadband and connect from my mobile phone because uh, it's raining heavily and I guess something has gone wrong with the broadband. Anyhow, let's start then, right? I mean, please put the attendance. I'm not going to say this again. It's there. So let's start. Okay, so um, this last lecture of this week is about a concept called exception handling. Okay. Now, even though we are going to study this concept with respect to C++, this concept is a generic concept. Okay, it's a concept that is applicable to almost all the modern languages. So when I discuss this, please keep in mind that the idea is to give you an overall overview of what exception handling looks like. There are many what can I say uh, there are many technicalities here, right, which are associated with C++ only. So that you can anyhow study from some reference text, if you are going to use exception handling, of course. But the idea is, please learn what is exception handling. This is the idea, because this is a generic concept. And some other languages, for example, like Java, their exception handling is used very heavily. So please, try to understand the concept more than the actual syntax. And to understand why something like exception handling is important, let us take a simple example. Assume that you are given the task of writing a user manual. Okay, so you've seen user manuals, right? User manuals for televisions, user manuals for washing machines, even these complicated toys which are there, right? Where you have to assemble them and then put a battery and all those things. Yeah. So what really happens is, in this so-called user manual, what are the things that the creators of the manual usually? There are two pieces of information, right? The first thing is really how to operate the toy normally. When I say normally, it means that when the toy is working in a good condition, what should we do, right? This is the idea. And the second part of information that these manuals often contain is basically troubleshooting. So if something goes wrong, what should be your steps towards trying to figure out the problem? Right? These are the two common pieces of information that you will see in any user manual. Now, if you want to include these pieces of information, there are two ways to do that, right? The first way is that basically I write the normal operation related stuff at one place, let us say in one section, and then I write another section for troubleshooting. And the other way is that I actually interleave, okay, interweave these things together. So wherever I have a troubleshooting point which relates to a normal operation point, so for example it says, now switch on the toy, and there itself I write something below, right? If the toy is not getting switched on, check the batteries, check the connection, so on and so forth. So there are two ways to do this, right? One is like this: you create a normal operation section in your user manual where you define everything normally, that this is the normal flow. In the normal flow, this is what should happen. And then you define a troubleshooting section, and there you say, if the toy is not getting switched on, do this stuff, like that. Or the other way is basically you do not create different sections, you just write everything in one flow. Okay, wherever there is a troubleshooting scenario, you just put it right next to that so called normal scenario. So which of these two options seem to be better, right? Frankly, the kind of user manuals that I have seen, most of them follow the first way, right? You basically first explain the user what exactly is the normal mode of operation, and then you have a section for troubleshooting. Why is it so? Because if, let us say, I've bought a new toy or new appliance, it's highly likely that everything is fine, right? All I just want to know is how to operate it, right? And similarly, when something goes wrong, okay, there's a good chance that I really don't need to know everything about the operations, right? I just need to figure out what should I do if this is my problem, right? So that is why uh, creating a user manual in such fashion is usually preferred over the other way around, right? Because the kind of information related to normal operation is put at one place, and the operations related to troubleshooting, any kind of error handling, is put at another place, right? So in programming, this exception handling phenomenon tries to do something that is similar to this first type of structuring, right? So it says that whatever error handling code is there, error handling as in whenever something goes wrong with your program, when something happens which was not expected, something that is not a part of the normal operation. Whatever you do, whatever piece of code you write in order to handle that, should be segregated from the code that is there for normal operation of your program. Okay, this is the core logic of exception handling. that you keep these two pieces of code separate from each other, the normal operation and the error handling. If you separate them, then this is the whole concept of exception handling. So in C++, there are three keywords that are used in order to perform such kind of exception handling. They are try, catch, and throw. So how exactly is this phenomenon going to be applied? It is something like this. You know what is a code block? A code block is nothing more than paired parenthesis. Whatever you write within paired parenthesis becomes a code block. So the first thing we are going to do is we are going to create a code block called the try block. Okay, so you just put try and then open a block and then write some code and close the block. So this piece, this block is known as the try block. And what do you do in try block? Write whatever code, whatever code is there in your program which is prone to some kind of exception, some kind of error. Okay, let me give you a simple example. If you are writing a program which divides two integers, you ask the user to input the divisor, but the divisor should not be 0, right? So this piece of code where the user entered the divisor, ideally what will you do? You will basically write an if condition and check if the divisor is 0, and then you'll say please enter something that is not 0, something like this. So this is a kind of error handling, right? By default you assume that the user is um, is not an idiot, right? That the user is not going to give me 0 as a divisor, but it's not completely impossible as well, right? So you should write some code to handle that. So anyhow, whatever piece of code, whatever piece of logic you have in your program that can involve any kind of exception, any kind of error, that should be put inside a try block. So now you can already understand that in many cases, the whole logic of the program probably goes inside a try block, because there are so many places where something can go wrong. Right? So in that case, you put the whole logic of your program within the try block. Then what happens? Let us say there are 5 different ways in which this particular code can fail, right? Let us say one is division by 0, another one is the user entered a string instead of a number. Third one, let us say, is that the number is too large, you expected a smaller number. So there can be many different ways in which even a division program can go wrong, right? So what you do is, if you want to, of course, as a developer, many a times we cannot, we cannot foresee all the problems that may come, right? But we try our best to handle as many as possible. So whatever pieces of code we would like to write to handle a particular type of error, this is important. A particular type of error should be put in a catch block which just follows the try block. Right after the try block, I put a catch block, and in the catch block, I'll show you what exactly is there in a catch block. In the catch block, I catch. This is the idea. I catch an exception. Okay, so if there is a problem, there is an error, I catch it in a specific catch block, and then do whatever error handling I want to do. Okay, so a catch is always associated with a try. Okay, a catch cannot exist on its own. Actually, try should not exist on its own as well. But there is a strong relationship between a try block and a catch block. Okay, a catch block should always be after a try block. Of course, it is possible to have multiple catch blocks. Okay, for a particular try block, you can have multiple catch blocks. The reason for it is, let us say, as I said, you want to handle 3 different types of scenarios. One is where the divisor is 0, another one is where the user entered a string, the third one is, let us say, where the user entered a number which is too large. There are 3 different error scenarios, and you can write 3 different catch blocks for it to, to put the code for 3 different types of error handling. So that is allowed. A catch block can follow another catch block. Then it is fine. But otherwise, but even in this case, this catch is actually associated with that try block. So let us let and by the way, there can be any level of nesting between these try catches, right? So within a try block, you can have another pair of try catch. Within a catch block, you can have another pair of try catch. So any kind of nesting is allowed, as long as a try and a catch appear contiguously, right after each other. That is the issue. So this is a typical try catch phenomenon. What you are seeing here is, there is, let us say, there is some application logic which I have written within a try block. Okay. Then this is one catch block associated with this try block. There is a parameter here. I'll talk about this parameter just now. But basically, this catch block is associated with this try block. So if any error occurs within this space, it is supposed to be handled here. Okay. Then you can write more application logic, okay, which does not require any try catch, and then you've opened another try catch block. Now some application logic here, and you've created with another try catch block within this catch block, right? So that is what I was saying, that nesting is allowed. So one try catch can go inside another try or another catch, something like that. And then again, whatever error occurs here, okay, only this part is supposed to be caught here. Whereas if an error occurs here, it is supposed to be caught here. Okay, and then there is more application logic that does not require any exception handling. So this is a typical scenario in which try and catch are used. Now, what the way you actually catch, in order to catch an exception, it first must be thrown. Okay, again, how will you catch something if it is not in the air, right? And how will it go in the air if you throw it in the air? That is the idea. That is the terminology that people use. Okay, so within a catch block, you catch an exception which was thrown using the throw keyword. Okay, and the throw keyword is used in a very simple fashion. It is exactly the same fashion that you guys have been probably doing already, right? So how do you do validations? You write an if condition, for example, and you check what exactly is that condition. Based on that condition, you take some action, right? So let us take the example of division by 0. Right after taking the divisor as input, you might check if divisor double equal to 0, see out, I need a non-zero divisor, right? This is one way to do validation. You might have been doing this already. So instead of doing that see out, divisor is 0, what you do is you put that whole code in a try catch block, and then you throw an exception from there, and then you create a catch block where this exception is caught, and then you put this cout statement there inside the catch block. So you might say, what exactly is the point of doing this, right? It is exactly the same that what we've been doing till now. The only point, the first point really, is that you are segregating the actual error handling part from the normal operation part. That is the first thing. And the second and more important part is that this exception handling stuff, um, it can actually go recursively, as in, let us say, you have a program where main calls a function f calls a function g, and g calls a function h. Okay, and the actual exception, the actual error, occurs in h, right? Now with your way of ad hoc error handling, it must be handled within h, right? Because that local variable is probably only available in h. But with exception handling, you can do this throw thing from h, and then it could either be caught in g. If it is not caught in g, it could be caught in f. If it is not caught in f, it could be caught in main, right? So there is a recursive thing, there is a hierarchical way of exception handling. Okay, an exception once thrown can be caught either in the same function where it was where it has occurred, or in the function which called this function, or in the function that called that function, so on and so forth. Okay, so this is a very important property of exception handling, that what you can do is, if you do not wish to write different types of error handling routines, you can just provide one generic error handling routine within the main, and then from there onwards, whenever there is a problem, you simply say throw, right? And then the control will eventually get back to main and print that generic message for you. Okay, this is a very important concept in exception handling, that exceptions basically flow from the point they have occurred till the point they have been handled. So this gives you a lot of programming flexibility, that you can actually keep all your error handling related code at certain places instead of distributing them across your code. Is this part clear? I'll show you the example of try and catch, but is the philosophy clear? I'll just summarize it again. The philosophy is something like this: you try to execute a code that may have some problems by putting it in a try block. Then, whenever there is a problem, you throw an exception which should be caught in a catch block, associated catch block with the try. If this part is clear, we'll go and have a look at the at a little more detailed example. Okay, so I think it might probably be better if we discuss this before we come back to questions. So this is a typical scenario of what we do when we are trying to do exception handling. In fact, let me just walk you through the whole the whole control flow here. So this statement is outside a try block, right? So the first thing happens is statement I is executed. Then the control enters the try block. Statement
Hello,
J is, yeah, go ahead.
sir. If we want to throw a error, we have to specifically add it inside a try block, or it can be, you know, put anywhere. Hello, sir. I'm asking that it is it compulsory to always throw a error in a try block? Yes, sir. Yes, you are audible.
Okay, okay, okay. Sorry. So using my mobile phone, right? So sometimes the signal goes away. Yeah, sorry, Yash, you can now ask your question.
No problem, sir. Sir, is it always compulsory to always throw a error in a try block, or it can be used anywhere?
Yeah, I'll show you an example where the throw statement is written outside a try block, but I'll tell you in what conditions you can do that. I'll show you a live example. But the idea is that it is not technically outside a try block. It has to be within a try block. It is just that the try block could be in another function. So I'll give you a very simple example. There is a try block, and within this, I'm making a call to a function. Okay, so let us say this try block is within the function f, and from the try block of function f, I'm calling function g. So in function g, you can have a throw statement without a try catch at all. Okay, so what will happen? The exception will flow from g to f. Okay, so that is possible, that within a particular function, and I'll show you an example. I've written some code where I'm doing exactly that. That my throws my throw statement does not belong to a try catch block directly, but it gets ultimately caught by some catch. Is it clearer? I'll show you an example. Okay, but first let me show you this scenario, so then you'll be able to understand what I just said. So this is state, by the way, I should keep on checking my internet connection as well. Sometimes it goes away. Okay, um where is it? So statement I gets executed, then control enters the try block. In the try block, statement J is executed. Assume that this statement does not have any probable errors, right? Let us say it is only a simple statement. Um, then the next thing is I check for an error condition here. Okay, I'm calling it error condition X. If this error condition X is true, what I'm doing is I'm throwing something, and the throw part is done like this: throw, and then you put a variable here. Okay, this variable could be anything. It could be a primitive type or it could be an object, but there has to be a variable here. Okay, and then this variable, let us say, is of type A, right? So what happens is, if this if condition is true, this statement gets executed and the control transfers here. Okay, so whatever error handling code you have written, that will be executed. Whatever error handling code is written here, that will be executed. Okay, otherwise, if this error condition was false, the control will simply ignore this, as it happens with if condition, and then statement K gets executed. Okay, then again I check for another error condition Y. If this error condition is true, I am throwing a variable of type B. So my control transfers here. The error handling code associated with this particular type of error is is executed. If this condition was false, I go to statement L. Okay, so now let us try to understand. In the normal mode of operation, what will be the flow? Statement I, statement J, condition false, statement K, condition false, statement L. This is the normal mode of operation. Okay, and right after statement L, statement M gets called. Now this is another thing that you have to understand. Statement M will always be executed. Okay, whether any error occurred here or not, statement M will always be executed, provided you are not exiting the code. You're not putting an exit statement in the cache. If there is no exit statement, statement M will always be executed. But if an exception occurred, what happens is something like this. Let us say if error condition X was true, so then this piece of code will be executed and nothing else will happen. Right after execution of this block, the control will come here. Okay, so this is another aspect of try catch. Whenever there is an exception, the try block is basically terminated prematurely. So statement K, this error condition, statement L will not be executed if error condition X is true. Okay, it's like putting a break statement here. You simply come out of this block. Nothing below the throw statement within that try block will be executed. Similarly, if this condition is true, statement L will not be executed. Right? I mean, some error handler will be executed. But once the error handling has been done, or if the error handling did not occur at all, right? You reached the last statement of try. After that, the control is always going to statement M. Okay, now I have some question. We consider statement M as it is surrounded enough. Okay, so yeah, finally is a terminology used in Java. So actually, yes, finally is in some ways like that. It is not exactly finally. Finally also has some other properties. So for example, finally is executed, I think, right before, even if you have a return statement within the try or a catch, the compiler will make sure that the finally is still executed, right? So there are some other nuances associated with finally. You can simply say this statement M is the statement right after the try catch block. Okay, right after the try catch block. It is exactly the same in Java also, right? Irrespective of what happens in try and catch, the statement right after the try catch always gets executed, provided you are not returning and exiting the code in between. If there is no return or exit, the statement right after try catch gets executed. So the same thing is here in C++ as well. Okay, so now after seeing this part, do you have any queries? Do you have any questions associated with exception handling and the whole idea, the flow of exception handling? I'll show you a code example as well, but first try to understand the concept, right? So let me repeat again. Whatever you put within a try block, that will be executed as if it's the normal mode of operation, unless a throw statement is encountered. If a throw statement is encountered, then it is equivalent to putting a break then and there. So it is sure that the next statement within this particular block will not be executed. Okay. And what happens, where does the flow go? It goes to the catch, which is matching the variable type of the throw statement. There the control is transferred, the catch block is executed, and by the way, only one catch block is executed at a time. If you want to actually execute multiple catches, there is another way to do that. We call it rethrowing the exception, but for now I'm not going to talk about it. That's a very specific scenario where you might need rethrowing. But for now, just assume that only one catch will be executed, not all the other catches. Only one catch will be executed, the one that matches the data type of the thrown variable. And then from there onwards, once the catch finishes off, the statement right next to the try catch block is executed. Any doubts, any queries on this? Okay, so now there is one more thing that we have to discuss before we jump to code. So there is certainly some questions that should have been asked, right? So for example, what happens if the throw uses a variable of a type for which there is no matching catch, right? So let us say there are only two catch blocks. One is handling variables of type, let us say float. The other one is handling variables of type string. But implementation knows to do for you is simply stop your program, terminate your program. So if there is a throw for which there is no matching catch, basically your program gets terminated because the terminate routine is called, which in turn calls the abort routine. So essentially your program gets terminated. Another reason where and by the way, to avoid getting your program terminated, you can always add a default catch block. So a default catch block is similar to the default case in a switch case, right? If none of the cases apply, then the default case is executed. Similarly, if none of the catches can catch your exception, you can create a catch like this. You don't really define a variable here, you just put three dots, three ellipses, and then you put a default error handler here, right? So this is the way to avoid the terminate part in case you are throwing an exception which cannot be caught by any of the catch blocks. So that is one way to avoid terminate. But if you do not have something like this and you throw an exception for which there is no matching catch, the terminate method will be invoked, and which will basically end in termination of your program. Another reason when terminate is called is when the throw appears out of place. This was the question that someone just said, right? So this out of place essentially means that you are not within an enclosing try block. And this enclosing thing, it is only checked at the runtime, as in you let us say there is a function which you have called, and this function has a throw statement. Okay, so you either need to put the try catch within the function itself, or even the function that is calling this function can also have a try catch block. I'll just show you an example of how this is done. So that is also fine. You are essentially enclosing the throws in some try catch block. Okay, whether directly or whether through the calling chain, function calling chain, right? That if as long as it gets caught through this function calling chain, it is fine. But let us say you are putting the throw statement within main. Okay, and there is no try and catch there. So then again it will basically result in a call to terminate. Okay, so this is another reason. There are a few more reasons where terminate occurs, but these are the two common reasons. One where there is no matching catch, the second one when there is actually no try catch at all. Okay, and by the way, you can write your own piece of code. If you want to write some specific piece of code to handle the terminate condition, it is possible to provide your own handler. I am not going to talk about it. It's something that you might require when you are building complex applications. But just to give you an idea, it is possible to change this behavior. Instead of calling abort, you can do something else as well. Okay, so any questions till now, or shall we go to code? Okay, so then let me show you some code. Hmm, share. Okay, I hope you guys can see my screen. You can see my VM, right? I hope.
Yes.
Okay, right. So let me show you this example. Now in that same toy domain, let me say I want to create a toy validator. Okay. So what does a toy validator class do? It basically has a function called create after validation. Okay. So I want to create an instance of toy, but I want to perform some validations before doing so. Okay. So for example, two types of validation that I have decided to do here is the name of the toy should not be blank and its price should not be negative. Okay. So I have created a class which is going to perform this task for me. Let me show you how this class is doing it. This is what this class is doing. Okay. The idea is something like this. It will validate if the past inputs are correct. If they are, then you simply return a new you return a pointer to a new toy, right? So I'm returning pointers, by the way. I'm not returning the toy itself. I'm just going to return a pointer to the newly created toy. So what I'm doing here is I'm basically putting a try and catch block. Within this try and catch block, I'm calling a function called check. Okay, and this check, based on what happens within this check, I'm doing something here. So let me also show you what check is doing. This is the check method. And by the way, there is a field called message within the toy validator class. So if something goes wrong, if the validation resulted into an error, then the message associated with it will be stored in the message field. So what exactly am I doing in the check function? I'm checking for the name, name's length. If the length is 0, I say name cannot be empty. Or if the price is less than 0, I say price cannot be negative. And what am I doing here? I'm just throwing something here, right? Which is basically a string. I'm throwing a string from here, and the value of this string is this. And here is an example. I have not put this throw inside a try catch block, right? But this is perfectly fine. Why? Because the call to check here is within a try catch block. So what will happen is, as soon as I do this throw, the first thing that the implementation will try to do is it will try to match it with some catch within the function. But then it will realize that this it is not contained within a try catch block. So then what will happen? It will immediately go back the calling function, and the control comes up here, and at this point of time it sees, are there any is it within a try block? It sees yes, it is within a try block. So then it starts finding a catch block, a matching catch block for it. So it keeps on checking, and then it says, okay, yeah, there is a catch block whose type is string. So I can actually pass on this variable, whatever has been sent back to me from here by the exception. Let me pass it on to this particular catch block, And here the only thing that I'm doing is I'm assigning the value message. I'm assigning this value m to the message part. The message part is whenever there is a problem, this is the message I show to the user. This is the reason why a toy instance cannot be created. Now I am using this trick here. Okay, it is a trick that if an exception occurs in the call to check, then this statement will never be executed. Why? Because as I said, a throw statement is more like a break statement. Okay, anything right after the throw statement is encountered never gets executed within the try, even if that statement is inside some function called chain. Okay, so it is possible that check may have called another function which may have called another function, but as soon as a throw statement is encountered, this statement, the next statement, is never going to be executed. So what trick am I using here? If an exception is thrown in check, then no, I will never go here. The value of temp will remain as null, and the message value will be set to whatever has been sent from the check function. And if no exception was thrown there, right, then the call to check will simply return, and this statement will be executed, temp equal to new toy 2, and then this is what happens. Is this flow clear to everyone? Any questions about this flow? So I'm making use of this trick that whenever an exception occurs, the statement right next to the exception will not be executed. Okay, so with the help of that, I can be absolutely sure that if the check function throws an exception, this particular line will not be executed. Okay, so the value of temp will remain null, and if an exception is not thrown, this will be executed, catch will be ignored, and I'll go straight. So this is like statement M here, by the way. You come here irrespective of what happens within try and catch. Okay, but there are two ways in which try and catch can fold out. If there is an exception, this statement gets executed and the message value gets set to something else. And if there is no exception, then this line gets executed and you have a new toy being created. Any queries on this? Otherwise, I'll just show you how the code works. Validation example.cpp. Here you can see that I'm trying to create a toy whose name I have put as blank, right? And again, here you can see that I'm again using a try catch, but here what I do is whenever I receive null from that create after validation function, right? If I receive a null, I throw an exception, and within this exception, I pass the type of toy validator. So whenever this happens, I come into this catch block and I put this cout statement. By the way, this cout statement could have been put directly here as well. Cout could not create a new toy. Reason v dot get toy uh, whatever it is. Yeah, v dot get message whatever it is. It could have been done here as well. No issues. Okay. So any questions on this part? Do you guys understand what is happening here? I'm making a call to that function create after validation. It can return either pointer to a new toy or null. If it is null, I'm putting it within the try catch block and I'm throwing another exception, and this time the type of variable is basically toy validator, and in this catch I'm simply putting out a message. If it is not null, then this statement gets executed, a new toy created successfully. So let me show you the running form of this program. It says could not create a new toy. reason name cannot be empty. I can change it. I can put it as like this: blocks minus 399, and then this time it says price cannot be negative. And if I remove this, then this throw statement will not be caught, will not be executed. You will simply come here, okay? You will jump to this part, and then uh, clean on. It says creating a new blocks with ID 1, a new toy created successfully, destroying the new blocks. Any queries on this? Otherwise, we are done. That is it. So the concept of exception handling, even if you are not able to understand the code, is the concept of exception handling clear? When do you use exception handling? You will use it extensively when you start building complex applications, because your code will be nested at so many levels. Okay, within the same function you'll have an if, then within that if you might have a switch, then within that switch you might have another if, right? So if an error occurs, this handling it at the place of it is slightly complicated, because my error handling code will be distributed across my code. So with the help of exception handling, you can neatly organize your errors and the error handling code at just one place. Okay, so this is the crux of the matter. This is the reason why we use exception handling. Then everything else is basically syntax. Okay, but at least try to understand what is the purpose of exception handling. And maybe in smaller programs you don't need it, but the moment you start building bigger systems, exception handling is used extensively. So don't don't get worried, don't be alarmed if you see things like try and catch and throw. Okay, this is why it is there. Even if you are not using exception handling on your own, if you read some code that is doing exception handling, at least you should be able to understand it. Okay, any questions? All right, then if there are no questions we can break. Okay, and thank you for waking up early for me. Okay guys, thank you, bye.
Thank you very much, sir.